So welcome back to more videos. This time we're going to be talking about tangents to circles. So first, there's just two things you need to remember when you're doing these questions. One, that a line from the center of a circle to the tangent is going to be perpendicular to that tangent. So that's really important. So like I have written there, that red line from the center to the tangent is going to be perpendicular to the blue tangent there. The second thing you need to know, you can get that distance from the point to the tangent using this formula here. And in this case, A, B, and C are gotten from the line, so it depends on the equation of the line, and x1 and y1 are the coordinates of the center of the circle. Yeah, and that distance from the center of the circle to the tangents, that red distance there, that's equal to the radius. All right, so those are the two important things to remember when we're talking about tangents to circles. So the first type of problem we're going to look at is going to be, I'll write it out here. So this is the first problem we're going to look at. We're going to look at getting the tangents to a circle at a point on the circle. So what do we mean by that? It's kind of like this example I have drawn here. So we're trying to get this red tangent here to the orange circle. So the orange circle is given, and we want to find the tangent, and we're given a point on the circle. So that's what we mean. We're trying to find the tangent of the circle at a certain point on the circle. So we're given this point here and the equation of the circle, and we have to find the equation of the tangent. All right? So I'll just write that down. So I'll say find equation of tangent. Find equation of tangent. So how are we going to do this exactly? We're going to use the two rules that we have up here. So first thing I'm going to do is I'm going to find the center of the circle. Okay, so I'm going to put a dot here, and we're going to find the coordinates of the center. So that means here we're going to have 2g in front of the x and 2f. So that means 2g is equal to minus 4, g is equal to minus 2, and then 2f is equal to 2, f is equal to 1. And if you remember that the center of the circle is minus g minus f, that means the center of the circle is going to be 2 and minus 1. Alright, so if we want, we can scribble that in. We can say 2 and minus 1. Okay, so now what we're going to do is we're going to get, I'll go green, the equation of the line, or just the slope of the line from this point here to here. So now that's just a badly drawn diagram, but that should be perpendicular. Yeah, because remember that was one of the rules we said. The line from the center of the circle to a tangent is always going to be perpendicular. Okay, so if we can get the slope of this green line here, then we can find the slope of this red line, because it's going to be the inverse of it. Alright, so I'm going to find the slope between the points 2 minus 1 and 5 minus 5. So we scroll down. So I'm going to say 2 minus 1. It's going to be x1 and y1, and then 5 minus 5 is going to be x2 and y2. Then m is going to be y2 minus y1 divided by x2 minus x1. That means m is going to be equal to minus 5 minus 1, so careful that, and 5 minus 2. Okay, so that's going to be on the top. It's going to be minus 4, so minus 5 plus 1. And on the bottom here, it's going to be 3. So that means our slope is minus 4 over 3. That's of the green line. So that means we'll say tangent is perpendicular. Tangent is perpendicular. So that means it's going to have the opposite slope. This means we'll say slope of tangent is equal to 3 over 4. Alright, so plus 3 over 4. That's the slope of our red tangent there. Okay, so now we have enough information to get the equation of the tangent, because we have a point that the tangent goes through, this point here, 5 minus 5, and we have the slope of the tangents. That's all we need to get the equation of a line. So then we can say 5 and minus 5, that's x1 and y1. We can say m is equal to 3 over 4. So that means y minus y1 is equal to m by x minus x1. So that means it's going to be y minus 5 is equal to 3 over 4 by x minus 5. It's going to be y plus 5 is equal to, so 3 over 4, what I'm going to do actually, now I'm going to go back here. I'm going to multiply both sides by 4, so it's going to be 4y. Remember, this is going to be plus 5. If we multiply this by 4, they'll get plus 20. And then if we multiply this by 4, the 4 in the bottom will cancel. We're just left with 3x minus 15. So that's the easiest way of multiplying those out. I'm going to move the 3x over here, so it's going to be minus 3x plus 4y plus 35 is equal to 0. And that's the equation of our tangent. And that's the question done. Alright, so I'll go back up, give a brief summary. So again, we're getting tangents to circles. You have to remember these 2 points, they're the most important points. And this type of question, we're looking for the tangent to a circle, and we're given a point on the circle that the tangent goes through. So what you're going to have to do is you're going to find the slope from the center point to that point. Yeah, so we got the slope is equal to minus 4 over 3. And we know that since the tangent is perpendicular to that line, that it's going to have opposite and flipped upside down slope. So instead of minus 4 over 3, it's plus 3 over 4. That's the slope of our tangent. And we have the point that the tangent goes through. So we can use y minus y1 is equal to m by x minus x1 to find the equation of the tangent, because we have a point and we have the slope. Alright, so that's that one done. Next time we're going to be looking at more tangents to circles. We're going to be looking at tangents to circles, but we're given a point on the outside of the circle. So we're given a point here, and we have to find the 2 possible tangents that can go to the circle. Alright, so we'll see you then anyway.